Hi everyone, welcome to the session. Kindly log in quickly. Hi everyone, log in quickly, all of you all. I hope you all are back from the EMAS. Just before we start, we should again have a discussion that did you have any problem executing the tags? Were you able to execute all the tags that we just saw in the previous session? If you have any doubt from the previous session, ask me before we proceed. Before we proceed to the next chapter, ask me the doubt. I hope it is clear so far. So without any issues, you have executed the MR practicals or tried their examples. Well, if you are not done with it, you can post the problematic questions where you are stuck, the solutions which are not completed. You can just upload those programs or applications in the group. I can rectify and resend it. Okay. Let us move to chapter number 9. Chapter 9 talks about again the life cycle of servlet. But why this life cycle is again given a recap? Because whenever we are sending any request to the servlet, it is not always that the servlet will receive the request directly, because there are other functionalities that the web container might have to do. Okay, like at the very beginning of the sessions, we had discussed that every request has got some header informations in it, which are used in order to give some idea about what kind of request to be sent, or any response that is generated out of the server, or you may say out of the servlet, also can fix certain types, certain kind of maybe values in the servlet object, in the response object, because there are some post activities after the responses are created. Let's say before sending the data to sending the response of this to the user, we might have to specify something, that the content which the users are trying to download maybe has to be zipped, right? So situations can be like this, wherein I have to perform certain tasks before actually executing the servlet logic, or it can be such that after the servlet is completed over with its response creation, it might return an object, it might return the response object, and while it is returning the response, we can make some changes again on the response object. Let's say we can add some data, we can add maybe date, we can compress certain data inside the response object, and then we can send it to the users, right? Send to the client. So these are known as pre and post processing activities. Okay, so we can just have a look at the demonstration. Before we look at the demonstration, let me have a look at the document camera, where we can have a discussion on this. For example, whenever the user sends a request to the web container is the first thing to receive the request and identify. Now, in the web container, we can figure out that what kind of request or to which servlet it is actually going to be sent. So, by identifying, let's say, the URL pattern of the servlet, what we can do is we can figure out that what other component can be created out here. Just 1 second. See, whenever the web container receives a request, before sending the request directly to the servlet, there can be some tasks which the web container might want to do. These tasks can be done just before the servlet starts processing my request. So we will call them as pre-processing request. Okay. Pre-processing tasks. Now, when the servlet is done with all the processing and it is about to, let's say, generate the response, there also we might have to do some task, or my web container can do some task which is known as post-processing. Now, web container has the capabilities to call upon programs which can handle these pre and post-processing tasks. These tasks which are done with the help of specific types of programs. You can say these programs are called as filters. Okay, so as they say that filters are components. So we can write it this way, that filters are components like the servlet, listeners, JSPs, etc. So these components will help us do some tasks before the request gets dispatched to the servlet. It can be, instead of servlet, it can be that you are trying to access contents like HTML pages or maybe some JSPs. Still we'll be able to handle them. Okay, so these are known as filters. Now, a filter has capabilities to control few things, like firstly, it can keep an eye on who is logging in the request basically, that is called as auditing the request. Alright. Now, auditing of request means we will keep a track of who are logging in to the site and who are sending requests to the specific servlet. Okay. This apart, we can get information such as on the request object to know the kind of contents that we may supply after processing, right? We can specify some algorithms for compressing the download files which can be obtained after accessing the servlet, right? We can transform the response by maybe changing the image contents, if any. We may check and block the users for unauthenticated access. And most importantly, there is something called as roles. Now, roles are what? Say there are few privileges which are grouped for a specific user. Say user admin has specific set of privileges. Say this is privilege set 1. There can be another user, let's say staff, another group, I should say, another role which has got again a set of privileges which are known as privilege 2. Privilege set 2. Let's say just that I've given it a name to identify that there are different sets of privileges given to the specific role holders, right? Now, whenever I will not allow all the users to access all the contents of the website or of the web application, right? We will allow the users only to access specific components, not all of them, right? So, what we can do is, due to some, let's say, due to some security reasons, we may do what? We may only access certain, only make the specific role holders access certain parts of the web application. Like we can put a restriction that maybe servlet A, servlet 1 or servlet 2 will be accessed by a role called staff. Okay. We may also say that say admin is the one who will be able to access say all servlets, right? We can say customers or consumers, let's say, will be able to access only specific servlet related to the consumer activities, right? So like that we can segregate. It is not only servlets, it can be any other component on the web container. So what we can do is we can specify all these by declaring filters. So we can give role based authorization if we go for declaring filters. Getting my point? So like it can block a user on the basis of the role or on the basis of the privilege. Now the filters will actually do what? It will intercept the request and it will not itself start generating responses. So remember that filters are there to intercept the specific request. Not all requests will undergo the filter. Request which has, most importantly, which has a mapped URL pattern. Like again, say you have a servlet 1, you have to send request to this servlet. So the servlet will have a URL pattern, let's say s1.do. Okay. Now there are other servlets also, maybe s2 and s3, okay, which has got separate let's say URL patterns. So whenever users are going to come with the request for s1.do, that means for this particular servlet, it has to undergo a check which will be done by filter. So it might be that you want to check or you want to get the request and do some work on the kind of requests which are getting sent, right? So whenever we will see that any URL pattern which bears this name, we will get those requests and process them through this filter. Whereas there can be users who are directly, accessing maybe servlet number 2. Getting my point? Because the filter is not applicable to it. So a filter will intercept only those URL patterns which will have s1.do. So this mapping needs to be done, that for URL pattern s1, for all types of all types of requests which will have URL pattern s1.do, call filter 1 or use filter let's say 1. Getting my point? For let's say all let's say .do, let's say for the rest of the .do kind of requests, please make use of filter imp, let's say. Getting my point? So I can either go for choosing one particular URL, or I can give a particular pattern that whenever, maybe whatsoever might be the URL, if you ever come across any component in the web container which has got a URL like star.do, is at the end the suffix matters, that is .do should be there. If you ever come across things like this, apply this common filter on all those kind of requests. Getting my point? Let's say if somebody has to access a view or some kind of view, so there can be files with servlet files with an extension of .view. So all the view kinds of requests will be sent to filter view. Getting my point? So it is not only that the filters will get the requests only. The filter can also work on the response. So what all we have seen, again to reiterate, firstly that URL pattern will be, first the request goes to the web container, the URL pattern is checked by the web container and it decides for which servlet to be called. But it will pause, it will stop, and it will try to figure out what kind of filters are created which can actually give a call to this servlet. Okay, so is there any filter which is mapped and which can be linked with the servlet? If yes, then the web container gets scope of doing some pre-processing jobs. Now similarly, when the servlet is done with its work, it has already executed the codes within the service method, it can do what? It can just make use of another program before dispatching the response, another program which is maybe filter number, the same filter or maybe the other one. Let's say take it as the same filter which will be again executed and a result will be shown to us, right? So this shows that there are, before servlets will do their own task, there can be some pre and post processing kind of work which we might see. And lastly, so the requirements of filters are because of the following reasons. Number one, we can use filters like for auditing purpose of the request, find out who all are logging in. We can use filters to get information which are required. We can compress say for example any response is to be downloaded, so we may compress the responses and then we may send it to the users, right? So these are certain ways by which we can handle the request and responses using filters. Lastly, another important point is, many a times we need to find out that whether the servlet or how the servlet is performing. So servlet performance is checked with the help of filters. Let's assume a situation where we may ensure that a request is coming for let's say specific servlet, and my filter will do what? It will, let's say, write a block of code to get the time. Okay. Now request will be sent to the servlet component. So servlet will be executing the logic which has been written already here in maybe some do get and do post methods. So it will be executed and the response will be given back. Let's say while the response will be returned, we may execute the get time method again on the response. So in a way we may record only the get time method while the response comes, right? So in a way we will get the difference between the request and the response, right? The request and the response. So we will be able to judge the performance, the kind of efficiency that the servlet is providing, or how much time, rather I should say, is taken in order to provide the the response, right? So entire time we can check with the help of filters. So performance and logging of the performance is also an important job which we can achieve with the help of filters. So are we clear till this much? Like why filters are used, or what is a filter? It is a web component which is there in the web container. Like servlet only, it is also made up of Java, the class, right? And it acts on a specific kind of servlet, or on a specific types of servlet, we can say, right? More than one servlets can be there which are passing through the same filter. The requests for those servlets are passing through the same filters. So these are actually going to do what? These will help us in doing some pre and post processing activities. So all the participants, can you just type the benefits of using filters, or what the filter is going to do? So we will have a collated answer. Can you just type it, just to reiterate and confirm that you have understood? Type the answers. All the participants, requesting you to type the answers. Why are filters important, and how do they work? Why we should implement filters? To check how, okay, the first answer comes in. To check how the servlet is working means the performance of the servlet, correct? And anything else that we have just discussed? Any other point? Srijita, Hema, Swati, Partho, Madhumita has written the right answer. I want answers from others as well. And Shuma. Let me just connect and see if somebody is. connected to Hardware Center. Yes, any benefit of the filter that you can suggest that we have just discussed? Hi, I hope I'm audible. I've only got an answer, only one answer I've got as of now. Requesting you to, yes. Yes, your voice is coming very softly. You can type the answer.
Hello.
Okay. Yes, correct. Now I can hear you.
Okay.
Yes. What you understood out of this? Just you tell me this, then we can proceed. What did you understand?
Ma'am, I don't understand videos. I got half one. I understood it as a different.
You did not understand this part.
Hello.
Yes.
I joined the machine.
Cannot understand, it's breaking, your voice is breaking. You type whatever you have to say, and I'll answer. Yes, Hema, you're right. It can access, filter can help you access specific types of contents based on your role. That's what I was telling you, to all of you, that if let's say we have roles like staff, admin, and consumers, etc. Yes, Swati, servlet's performance can be checked, right? Somebody's already said. Vima, you're also right that based on the user's login and the kind of role they hold, we can decide that which servlet they will be redirected to. Right? Once we get to know about their who's logging in, and based on that we can lead them to some other servlet. And if they don't have specific maybe permissions, then we might stop them and block their request. It's not that we will always cater them with the servlet. We may, in fact, with the help of filter, block the accessibility also. Ma'am, filters, the definition you want me to repeat? Okay. See, digital filters are components, okay? Web components, just the way you keep servlet. We call them as container managed objects, okay? We call them as container managed objects. Now, these container managed objects are, you can say, one such thing is filter. So filter is a class, it's a Java class, and it has got capabilities to intercept requests. Like your web container, it accepts requests. Similarly, if the web container has got a lot of capabilities, so one of the capabilities is to accept the request and find out that what kind of URL patterns are there in the request. Then the web container can simply look for a filter if available for a particular servlet, right? It will, like I was telling you, just 1 second. Like I was telling you, that before, when the request comes in, the web container will check whether there is any kind of filter available or not for servlet, let's say s1.do. For all these type of URLs, if there is any filter made up or not. If yes, then it is supposed to call that filter and it will pass the request to the filter. Now filter will decide what it has to do. Maybe it has to do some checking, maybe it has to execute some code to find out the privileges, roles and responsibilities of the particular user, right, credential. Now then the filter might feel like dispatching it to, feel like means I should not use that feel like word, but if the filter finds it that there is an associated servlet available, it can dispatch the request, or it might dispatch the request yet to some other filter, right? So we will come to that later. Firstly, till this much. Okay. Now there can be maybe some HTML pages only. So for HTML pages, I might have some other filters associated. So whenever the web container will find that HTML page kind of requests are coming in, it might redirect us to the second filter. And then all the HTML pages will be accessed. But before accessing the HTML pages, maybe there has to be some changes done. See, nowadays users are very specific about their responses, right? Let's have a very practical example. See, if the requests which are getting sent, these are, let's say, sent from different devices altogether. Now, the browsers of all devices will not be same, right? Say, user A is sending a device from mobile phone. Let's say user B sending a request from, say, laptop. Let's say user C is sending a request from, let's say, some other systems. Let's say he's sending the request from some web service to this application, right? So how would I know that what kind of requests are coming to me? So I can check them using the filter, right? And just because my filter knows that if this is the type of mobile kind of requests are there, just call a servlet for mobile related operations will be taken care by the other servlet. Getting my point? Whereas if I find that if the request is coming from, let's say, Mozilla, and let's say the version of Mozilla is, say, 9 and say above, right? Then we can allow some animation effects or high quality HD multimedia files to be appended and sent in the response, right? So filter will be able to help me in all these things. Are you clear with this thing? Is it clear to this Srijita? One second. Is it clear, Srijita? Is it clear?
That step only I'm missing. Ma'am, that final step, no, ma'am.
Hello?
Hello?
Yes?
Hello, ma'am?
Yes, I can hear you.
The final step which you have done, that final step, ma'am, that animation, that animation, that Mozilla, if it comes from Mozilla, what is that doing, ma'am?
Okay.
Document you are trying.
Just hold on. See,
okay.
The thing is that you are sending request maybe from your mobile. Okay, so the browser of mobile will be different. This is a different browser you have in your mobile, right? Maybe sometimes you might use a tablet and there you have a separate browser installed. Okay, so this is browser number B1, right? And there can be again situations that somebody is using their laptop and is using IE, Internet Explorer, in order to access anything, right? In order to access their website. Now these requests will be sent to what? To the web container. Now web container will make use of something called as filter in order to find out that which kind of requests are these and what kind of component it is asking for. Let's assume that it is asking for a component to let's say to check balance. They all are accessing a component to check the balance in their account, right? But they can SMS and do the checking. They can, you can say, they can send the request using, say, some browsers. They can send the request using some smartphones and whatnot. So my filter can do this. It can do a checking on what kind of browser components are these, what version do they have, because like you know that every request will have some header information, isn't it so? We discussed in the very preliminary classes. So those information we can check, and because after all this is also a Java component, so we can figure out that what are the types of requests. Accordingly, we can decide that okay, not only the request will be processed, but when the response will come, my filter will identify the response and maybe will allow some applets with this. Maybe it will allow some multimedia content. It will allow some multimedia content, or let's say sorry. Yes. Microphone. Bring it to your mouth. Bring the microphone closer to your mouth. Say.
Ma'am, this filter you are telling that this filter will check for the type of these three, like one is from IE and one is from Mozilla and one is from like Chrome and all. What type it will check, ma'am? Is that any specification for type, ma'am?
Yeah, just like we discussed, that every request has got a header part, isn't it so? We discussed that every request which is sent, it is not only a URL, but there are headers also associated with it, right? So by checking the headers has got different things like user agent, that is the browser name. Headers will have the content specifications, the connection type, and various other information, right? So by checking all these parameters, my filter can decide the kind of request it is, or what kind of content will be suitable for this, right? Whether there are some specification in the header which will allow zipped documents, so it can then make the response convert into zip, and then it can send it to the client. Are you getting my point? Okay.
Yes, ma'am.
Okay. Thank you.
Thank you.
So these are all the things that we may do using the filters. Okay. Are we clear now on this? So okay. Welcome, Srijita. The thing is that so this is the concept of using filters. And before we go ahead with it, we should again have some discussion about an important topic which is a part of chapter 9, but though it is not very largely discussed over there, and it is very important nowadays for the students to know, because it is very much in the industry, it is very much needed, and they ask questions on this. That is something called as, here they have just given a slight definition of something called as dependency injection. Okay, so what is this? We will see. Why we will see this? Because while we will have a look at the code of filter, we will notice that in the filter code we are implementing things like dependency injection. Alright, so dependency injection is what that we will see before we move further in detail into the filters, right? And later we will know that what we can do with filters, like how do we configure? We configure filters, we can create filters, we can in fact like find out if there are some errors happening, then we can again configure the filter to transfer the request to or transfer the response to an error page, and so on and so forth. All these things will be discussed, and how it operates basically we will see then. Okay. Now firstly we will see something called as dependency injection, which uses dependency injection is a concept, you can say. Now, based on this concept, Java has given us two annotation types. One is called post construct, another is called as pre-destroy. So these are very asked in very discussed in very small amount, but we can tell our students that they can go for e-learnings which are provided there. Maybe we'll have some more content out there. In fact, you can also go through the e-learning portions wherever you look for some more information. Right? Now have a look at this, that dependency injection is required because earlier whenever we used to create classes, and we used to create objects of the classes, there were situations that my classes had relationship with another class in a very strict manner. Again, let me repeat. Say if I have created a class, let's say class A in Java, and I have created another class, class B. Now I am saying that okay, class A can only work if it has got objects of class B. Okay, class A will use the objects of class B, and then only it can give the final output. Okay, so the thing is that I am completely dependent on, or my class is completely dependent on B. So for functioning, for making things go right over here, I have to completely be, based on class B. Now this is not good. Why? Because tomorrow if this thing is not available, then I have to change the entire setting of class A. Are you getting my point? Just hold on for again. Say, let me explain you with a different example. Say you have a class called as email service. Okay. Now email service has got a method as, let's say, send message. This is the method which will take some string kind of parameter as message, and let's say string as receiver. Okay, so let's say this will be the method which is there in the email service. Now I have a class, let's say application, class application, which will help me to implement the email service. How? Say I will create an object of a class email service, and I will email, say service ES equals to new email service. Say I will create this. Fine. Now I will have a method as public void send, and within this, say I will take some parameters, string, a message, and string receiver, and I will give a call of es dot this send message, and I will pass message, this message, and this receiver's name into this. Okay, so class email service has got its own method called send message. Now another class is actually creating an object of the email service, and it is doing what? It is having a method called send, and it is calling the email services message sending system to send the message to the respective recipient. Right? Now the thing is that if tomorrow, if my organization, let's say something goes wrong, and if the organization has to change the email service vendor, then what will I have to do? Then the entire application needs to be reconfigured, because if you will notice, this method depends on this object. It is an email service object. Okay, these parameters have to be sent over here, right? So there is a direct linking, a very strict bonding between the classes and objects, between the application class, let's say between class A and class number B. This is what I was trying to tell you. So this is called as tight coupling. Tight coupling. Alright. So this tight coupling is never a good idea. A developer who is organized will always go for modularizing codes. Will always go for simplifying the codes in terms of modules, and will increase or look for flexibilities. Right? Say now there can be situation that I have new let's say possibilities are coming up, so business possibilities are coming up, so I have started implementing, apart from mailing service, SMS service, Facebook applications, services, okay, and then messaging services, and then maybe WhatsApp services are there, and all of these. So in that case, I will not be able to strictly depend on email service. I will have to already, if something new comes in, then again I have to adapt that. So I have to make my current application so very flexible that it can adjust the different objects, different variables in its class, and it can give the same service without making changes. What is the problem currently? So in order to overcome this problem, we have come out with a new concept called as dependency injection. Okay, we have come up with something called as dependency injection. So first you tell me, have you understood the problems, the limitations of earlier application developed before dependency injection? Have all of you understood the concept of the problems which were there? Then we may discuss dependency injection. Is it clear to all of you? Okay. Srijita again. Good. Hajra Center student, you have understood. Well, Srijita, see. Again, let me show you this. See,
ma'am, this message is being. Ma'am, this message is passed to the send message as the parameter, ma'am.
Yes.
This send, it is sending to this message as parameters. And why this is considered as tight coupled?
Okay. Say I have an application which has to take help in order to implement the message sending system. No, it has to depend completely on the other classes object. Say you are running a telecommunication company's application, and you, for doing every payment, you have to make a payment application module. Is it clear? Now payments are never going to come for a specific bank. So if you create a standard maybe State Bank of India's you can say applications variable in your software, you cannot expect only people from State Bank will be purchasing your products. Getting my point? Actually, not here.
Yes, ma'am.
Just have a look at this. Say you have an application which will, say you have an MTS application, right? For paying MTS bill,
yes,
you can access, say, Paytm. We can use Paytm, right? If Paytm has its own service, so if I create an object of Paytm application and I can fit into, let's say, this application, don't you think there will be a close, relationship, close bonding between my MTS application and the Paytm? Getting my point? But can you confirm that only Paytm people will be, coming for booking MTS services? Can you guarantee this?
No.
Okay, you cannot, because there can be n number of users. Your business requirements can go beyond limits. So, and that's why maybe other users will also come. So you have to customize your application every now and then. Whenever a new vendor comes up, again you have to customize your application. Maybe whenever, let's say, Visa, MasterCard comes up, again you have to carry on customizing your application. So that means why you have to customize, because there is a fixed relationship, right? If it would have been loose, if it would have been adaptable, then even if this part was missing, I could have done it with some other thing. I don't have to make some changes. Are you getting my point? I won't have to make some serious changes. So that is what is called, that was the problem, and that is why we are coming up with dependency injection. Is it clear?
Yes, ma'am.
Okay. Now in dependency injection, what we are doing is, we are telling, again taking the example of email messages, what we are doing is, we are going to create an interface called message service. Now message service interface will have a method called, let's say, send message, and this whosoever will implement this interface will be eligible for my application. Let's say I have got email service for implementing the message system. I have got SMS service for implementing the message interface. I have got, let's say, WhatsApp service for which is implementing this interface. So everywhere in all these three services, in all these three applications, I will get this send message available, because this is an interface. This is an interface, and message service interface is utilized by all these three applications. So the send message will be a common factor in all three of them now, right? Now what I am going to do is, in my application I will create a method. This is, say, my application. I will create a method which is, let's say, accept service. Now the accept service method will be, see, the message service interface M. Now if I create a method, let's say, which will accept any content inside M, which can accept any content inside M. Now this message service is a particular, you can say, message service is a particular interface whose data type I am using and whose that kind of variable I have created. Now currently the variable is empty, but the moment my company goes for, let's say, using email service, I will create an email object and pass it inside this. Why? Now you will say, ma'am, but this is an interface variable and this is a class object. So how does it fit? It can very well fit because of the interface, right? Because interface is already implemented by this class. So they are in a contract, they are in a relationship. Now if I pass the E inside this object, message service becomes activated. If I pass, let's say, S, then also messaging service becomes activated. If I can pass, say, W, then also my messaging service becomes activated. But did we actually create any direct object in the application? No. We are just creating an interface type, and we are saying that whosoever falls into that contract can easily be adjusted into my application. Whether it is a WhatsApp system, Facebook system, send message system, SMS system, and email system, whatsoever, messaging will be done if it follows the contract interface. Getting my point? So in a way, if something has to be removed, I don't have to change anything out here. Maybe instead of email, something else will come. Fine, I don't have a problem, but my application does not have to change. So this is what is known as loosely coupling. Okay. So dependency injection is helping us to do what? It is helping us to loosely couple my application. Getting my point? It is not tightly dependent on each other. Each modules are loosely coupled. Are we clear till this much? Is it clear? Is it clear to all of you? Please type yes so that I get to know. If okay, I have got the answer from Hardware Center. Others, if you are not through, can ask me. No problems with it. Okay. Okay. So are you through with the concept of dependency injection?
No, almost.
No. Okay.
Hello?
You are not there.
Hello?
Yeah, hello?
Hello?
Yes?
Can you hear me?
Yes, I can hear you. Can you hear me?
Please.
Okay.
Yeah, it's
So are you through with the problems of dependency injection?
Yeah, I'm not very confident, but yes, that's very confident.
Can you share what you have understood?
I think I need to go through the content once again before
So I really doubt whether you are attending or not the training.
Yeah, I am hearing it. I was there.
Then pay attention. Okay. Fine, no issues. Go through it once and then let me know. Well, everyone else, Swati and Hima, are you clear with this? Hi, Swati. Yeah, are you clear with this? Hi, Swati. Are you clear with whatever I have just discussed? You type it and tell me. If anything you want to ask, I can repeat. If you have any doubt, let me know. Well, before we move ahead with the other part, now let us again have a look at where we were. So, like we discussed that there can be situations where we are going to make our applications maybe very, dependent on each and every module, right? So, in order not to follow this, we can implement a concept of loosely coupled application, and the thing is that for doing so, we have to create a method maybe where we will create. Why I say a method in the class? Because a method can accept parameter of an interface type, and if I can get any particular object which comes through that interface, which comes via that interface, then I can consider as it's acceptable for my application. Now, filter class has also got such constructors wherein it will accept any kind of any kind of, in the sense, filter config objects. Say my filter class has been made in such a way that it can get another interfaces object. Let's say this is an object of type interface. This is an interface whose object is this. So what we can do is we can get really loosely coupled objects over here in this variable, and later on utilize this variable in my filter. So prior to this, if any object is not coming, my filter class is it is not even aware of the fact that what object is going to come here. Okay, so it is completely unaware that what kind of objects will be coming here, and that what content will be there in this object. All it knows is that it has to be of a particular interface type. So this structure is known. It is implemented keeping in mind about the dependency injection. Getting my point? So here what we are doing is we have to create filter, and the configuration detail about the filter will be saved in an interface type called filter config. Alright, so they have got two, if normally what happens, the object of filter or servlet, they all get created automatically by the web container. So here also, in this case also, the web container will create an object of the filter class automatically. Getting my point? It will be initializing that object, it will be creating that object automatically. But let's say if I have a variable, and let's say I don't have a reference of that variable. Say in a class, let's say my class, I have a variable as say m, and let's say the variable is not yet initialized, and I expect that later on down the line I will be populating this variable with some other class as object, right? So just as of now I don't have any reference for m, so the moment I will try to initialize, I will try to, let's say, create object of my class, I will face a problem that I cannot find any reference to store in this, right? This problem can be overcome by an annotation called @post construct annotation. Now post construct annotation is doing what? It is telling me that okay, if you have any such variable in your class which might not get the reference objects, which might not get the reference of objects right at the creation moment. Say for example, I have opened up a business and I don't have a post of, maybe I don't have a person for accountant post right at this moment, but my post is there. It will get populated later on. Similarly, post construct will do what? It will check whether there are any variables or any objects which are going to refer to some other classes objects, and it's not yet populated. If these two criteria are there, then what it will do? It will try to use @post construct, and while this my class object will be created, later on the objects of other classes will be filled up in my class object. Is it clear? Now just because of this annotation is available, we can ensure that my application gets loosely coupled. Now apart from this, we will have to see that what my filter does. We can max to max do with my filter. I can chain my filter with other filters. I can make sure that my filter can transfer data that it gets. It can transfer data into some other servlets through request and response. It may, in fact, it may send the request. Let's say servlet 1 is sending a request to servlet 2. Servlet 1 is sending a request to servlet 2. So some filters are applied out here. Now again servlet 2 sends a request to servlet number 3. Again I can chain other filters in the process. Getting my point? This is called as chaining of filters, right? Now in order to make my filter work, I need to implement two interfaces. There is something called as the filter API, which is a collection of filter classes and interfaces. So any class which has to take part in becoming a filter has to inherit from, say this is our users class, user defined class. It has to inherit from the filter class. Okay, and filter class will have two implementations. One, it will implement an interface called filter config, and it will also implement another interface called filter change. Now if I want to do some processing and I want to transfer the control from my filter to a servlet, then I can go for a method called do filter, and we may go for a method called do filter, which will help me transfer the control, transfer the request to some other, maybe servlet or any other component, maybe another filter or whichever other component. Getting my point? So these are the things that we will be discussing. Now let us have a look at the demonstration. To create a filter, just have a look at the projection screen. Just have a look at the projection screen. This is my first page, which is known as index.jsp. Now in index.jsp, I have got 3 links. The first link is connecting me to a servlet. The second link is sending the request to a product, and the third link is sent to about.html. Getting my point? So these are 3 links which are provided. I might send I might go for clicking servlet 1 or servlet request, so I will be taken to a servlet. If my request has to be for a particular JSP page, that also I can click. I'll have to click the second link, and I'll also have to click the third link. Getting my point? Now what happens is, say I have to create a filter to intercept all these 3 types of requests. A filter can be created for different kinds of components. So say this is a sample filter which I have created, which will manage all 3 kinds of requests. It will be working against all .do types of files. It will .do types of requests. It will also work if somebody is sending requests for JSP files. It will also work if somebody is sending requests for HTML files. So before we move on, just have a look at what are the different files where this filter will be working. Now there is something called as filter mapping. This is very, very important. There is something called as filter mapping. Just the way we did servlet mapping, there is something called as filter mapping also. This is the filter named sample filter might work, or this name called sample filter will work for the 3 kind of requests. There might be a request that servlet1.do, which is pointing to servlet 1. There might be a request for about.html, or there might be a request for products.jsp. So out of any 3 URL patterns, if any URL pattern is sent, then this filter will start doing its work. Getting my point? Now there is another thing that is called as dispatcher. Now dispatcher is again very important, because dispatcher tells you like filter will be activated for which purpose. For all the incoming requests from the browser to the web container. If it is so, then we will write request. If we are let's say forwarding the existing request to some other servlet and it has to go through the filter, then the dispatcher value will become forward. And if the let's say dispatcher is going to include some additional file with the current response, then the dispatcher value will become include. And finally, if the filter has to work against some error situation, then the dispatcher will be error. Okay. So what are the 4 values that it can be? Just type in. What are the 4 values that it can be? What are the 4 values that can be provided in the dispatcher path? Include and forward, correct Trijita, others? Hema and Hema, Madhumita, Jhuma, Swati, type the answers. If the communication has to happen between browser and let's say a servlet, then it should be request. It should be called as request. If the communication is happening between one filter and a servlet and then another servlet, it is between 2 servlets, then we can say it is a forward kind of a dispatcher. If I already have a response and I want to get another page added with my current response, then it will be an include kind of dispatcher. And if there are errors coming up, okay, then we will say it is an error kind of dispatcher. Okay, Are we clear on this? Okay. So now let us have a look at this. That means there are different types of let's say URL patterns against which my sample filter will work. So now coming back to the filter, this is my package. If I have to create a filter, I have to follow the following steps. What all steps? Say I will go for clicking onto the filter pack, then I will right click on this and click on to new. Okay, and then we will go for using the filter option. Say the moment we'll click on the filter option, we will get wizard like servlet. We will write here, let's say the name is new filter, can give any name, and then we will click on to next, right? Now they are asking that for which particular kind of request I will be using this filter. So it will be applicable for what kind of request? I can edit it. I can write over here as all dot do. Let's say if I write here star dot do, that means all the dot do kind of request will actually be using this particular filter. Okay, and it will this let's say whichever users are actually providing. Just hold on. Say if I go for right clicking on filter pack, and if I go to new, and if I go to filter option, I will get the filter wizard, right? Now I'll have to first give the name of the filter, then I have to click on to next, right? Then I can provide the detail about what kind of URL patterns will be mapping to this very filter. So I can provide here some URL patterns like dot do. Okay, I can provide URL patterns like, let's say dot do or dot HTML, so that all the HTML files will be using this very filter. So all the servlets will be using this very filter. Like this we can specify. If I will specify here dispatch equals to request, that means I am planning to only use the filter against the request kind of work. If I have any internal dispatching, like from one servlet I am dispatching the request to another servlet or to another JSP, then there is no browser to servlet communication. There is servlet to servlet communication. If such kind of things are happening, then we can go for forward kind of dispatcher. If there is one response and we are including another response with it, then we should say it is an include kind of dispatcher. And error is when we are actually forwarding our request to some error, then it is error kind of dispatcher, right? And we will click on to OK. Say we will select request and we will click on to OK. Now automatically my new filter will be available for all the for let's say all the dot do kind of requests. Okay, and we can click on to next, finish, right? And my filter will be created. So this is the way how we can create a filter, right? Now what happens is, say I have a filter already created called as sample filter. So I have applied this filter for 3 specific files, one servlet and one JSP and another HTML page. Now here you will notice that there is a method called do before processing. Do before processing method is given here so that before the actual request response goes to the servlet or whatever page is available, before going there it can do some processing work. So I have just made it very simple. I have just printed a message as filter is doing pre-processing, right? So I have written filter is doing pre-processing, and I have given a time I mean, we can give a time as in milliseconds, right? Like how much time, what is the current time in milliseconds that is there, and once the filter goes to the servlet and comes back, how much time or what changes are happening. You may give this or may not, because it will come in milliseconds. You will not be able to, maybe we can track that way. So let us just, for the time being, I'm removing this. Just only follow the text message. Now after the tasks are done, now then we will have to execute the do after processing. Do after processing is a method which is going to do some tasks, right? After the servlet or whatever pages are there, after it has been already executed, it will do some task and then it will come out. So the do after processing will use a println command to display that it is doing the post processing work. I'm just going to remove this, not needed. It will do the post processing task, right? It will only give the message. Now again we will have to see that there is a method called do filter. Now this method will take three parameters. One, the request which is coming. Two, the response that it has to generate. And three, the filter chain variable. The chain variable will be responsible for calling the next component. So whether it is a servlet component or whether it is another filter, nested filters are there, or whether it is maybe a HTML page or whatever, right? So chain will help me that where my filter will be sending the request to, right? So here we will specify that chain.doFilter. So filter chain is an interface. I told you that which filter class implements. Now this variable will be helping me to call the method called doFilter and will send the request to the next level component. Getting my point? And we will process it. Let us now run and see. Just hold on for a second. Let me just build it once and then I just have to remove my already newly created filter. Just 1 second, I'll remove it and then we may get the execution done. Now here we go. Now if we click on to the first link, then we are taken to the page called filter is servlet 1 page where it says that filter is doing pre-processing. Just have a look at this. Before the servlet page is getting called, the output comes here on top. That means what? In the output, we are printing this message in the filter only, in the like while sending the request. Now, when the servlet is getting called, what happens? We get the servlet page and this message comes up. And when we go out of the servlet, then this message gets printed in the filter only. So that means what? If my request is going through filter 1, the response will also come from filter 1. Okay. There can be multiple filters also for a particular servlet. So if the first filter is going to be called at the beginning, the last filter will be called, in the response, the last filter will be called at the first place. Showing you this. If there are multiple filters placed, filter 1 and filter 2, and there is a servlet 1. So the first filter will be applied to the request, and then the second filter will be applied. Okay. Now when the response is coming, the second filter will be applied first, and then the first filter. This is the order of execution. Okay. So if I will now go for clicking the About Us page, just have a look at this, or this HTML page, the same thing happens again. This is an HTML page though, but still the filter is working in the same fashion. See, if I am sending a request to the About Us page, still it is working in the same fashion. If I am sending a request to product request, okay. Now here I should write products.jsp. I need to write JSP in the map. So whichever place, just hold on for a second. For this specific filter, I will have to give a name as filter URL pattern, and then say product.jsp. Build, and just running it once again. So again it is doing the processing, right? So are we clear with this? The different types of pre and post processing which can happen, how the filter will work, and how the filter will work, and how do we specify the URL pattern in the filter, and what is a dispatcher. So are we clear with this? Each one of you just go through and let me know right now. Quickly check and let me know the interfaces that we can use, difference between filter chain and filter config. Just go through and let me know. Okay. Well, I'll just give a recap, but still you just go through and again let me know. Just let me know whatever doubt you have. I will give a small recap right after you finish up with your doubts. Let me. Hi, Hema. Are you through with this? Do you have a doubt? Am I audible? Hema? If you have a doubt, type and tell me.
Yes, ma'am.
Hema, you're through with this entire process of filter?
Yes, ma'am.
Okay. Can you just tell me what is pre and post processing?
Ma'am, the thing is, I'll not be able to explain right now. I think I have to read it again.
Okay. You need a recap?
Will be fine.
Okay, fine. Yes, the Garia student has rightly said pre allows process the request and post gives the respective. See, it does not give the response, but it processes it. Just giving you a quick recap on this before we wind up. And a document camera. See, this chapter talks about few things. The life cycle of servlet, which we know that first we'll have to accept request, then maybe the request will be received and the servlet object will be created. Okay, and the servlet let's say class will be loaded, then the servlet object gets created, then initialized, then it processes all the service. It processes all the requests. We call the service method init method, and finally we go for calling the destroy method to destroy the servlet. Something similar to this happens with the filter also. The filter is also component of the web container. So a filter, let's say, accepts request. It also gets, this class also gets loaded. Instance is created, object is created. It is initialized but not completely, because partially maybe or the few variables can be there which are initialized later. This can be done because of pre-construct annotation. Number 5, there can be let's say there can be a situation that the filter is no longer in use, so we go for calling the destroy. So before we destroy the filter, we might have to again let few objects be removed and then destroy the filter. So this is post construct, and so we go for pre destroy, so that before we remove the filter, we should remove all other dependent objects on it. Now, how the entire filter works, that is, any request which is coming might bear a URL pattern as .do, or it might have a URL pattern as .html, or it might have URL pattern as .jsp or something else, right? So we may just only select the .do types of URL patterns, and we may call for a filter. This filter will accept all the .do kind of requests, and it will then let you go to the servlet. Now similarly, when the servlet will process the request and it will come back, it will come via the filter and it will then give the response. Now what benefit it can bring? It can bring few benefits, like it can do the auditing of the users who are logging in, who are accessing the servlet. It can monitor the servlet's performance. It can monitor servlet's performance. It can audit, monitor the servlet's performance. It can also go for, let's say, compressing some files if required, compressing the response if required. Okay, and it can also let users access based on roles. Okay, so these are few benefits that the filter is going to provide. Now this is not only the case, there can be another situation where maybe my .do kind of requests are getting sent to filter 1. Now from filter 1 there can be a situation that instead of, say, I am sending the request after doing the pre-processing work, I am sending the request to the next servlet. So here again I will apply another filter. Right? So there can be one filter, and then again between servlet to servlet communication there can be another filter. So this is known as a forward kind of a dispatcher, when one servlet is communicating to another servlet, and this is something called as request kind of dispatcher. Okay, and so after doing forward and request dispatching, there can be again a situation that I am waiting for the, say, I am actually generating a response out from this servlet, and at the same time I am also adding one new, I am including some other files along with this response. So then we will call it as an include kind of dispatcher. So my point is, filter can work on all these 4 cases. And finally, if I would tell you that there can be situations where my application is throwing error, then my filter can also work for all the error kind of pages, right? So these are certain things which are there about filter. And in order to create a filter, you have to implement few interfaces like, say, filter interface, filter chain, which will help me do this chaining, means transferring from one servlet to another servlet and things like that. Filter chain will be able to call the next component in the chain, and there can be like a filter is a class, so it can also have a variable which might get populated when the object of filter will be created. So in order to call the initialization parameter on filter class, I will have to use filter config, which will contain information like name of the filters, the variables if any in the filter, the data in the filter, all these things will be included. So are we clear now with what is filter in short? Is it clear to all of us? Is it clear? Just let me know if all of you are through with this. Sejita, you have a class which has got a variable as int I, which is, say, whose value is going to be 10. So this is known as class A, whose value is going to be 10. If you create an object of this class like this, class A, say C equals to new class A, don't you think that this I variable will be created and the value 10 will be set inside it, right? So filter is also a class. Filter can also have a variable with a default value, and so whenever filter's object will be created, the filter object is getting created, it will also create the variable or the initialization parameter and set some value inside it. So the initialization parameters can be accessed with the help of something called as filter config. Config. Filter config will help me access this. So are we clear with this? Like what all initialization parameter a filter can have, the name of the filter, the data variables, if any, all of those we can get. Is it clear? All of you? Okay. So if you are through with this, just go through the demonstrations once given in the book, and go through the portion, because some of you are still having doubt. Let me know tomorrow. We can again have a small discussion on the problematic areas only. Okay? Okay. Thank you everyone. Okay. Okay. Fine. Thank you.